What if a smart contract could read a website, understand a natural language instruction, look at an image, and actually make a decision based on real-world information? I mean, that sounds literally impossible for traditional blockchains, right? But believe it or not, this is exactly the problem GenLayer is trying to solve. Okay, let's dive into this. Instead of asking the standard question we always hear, can blockchain execute code? GenLayer is asking an entirely different question. Can a blockchain reach consensus on decisions that actually require human-like judgment? And honestly, that's exactly where things get interesting. Welcome to today's Explainer, GenLayer Review, the blockchain that lets AI make on-chain decisions. I am incredibly excited to guide you through this one today, guys, because we are looking at something that fundamentally challenges everything we thought we knew about smart contracts. We're going to explore exactly how GenLayer tackles this completely wild, paradigm-shifting premise. So here's our roadmap for the day. First, we'll look at the smart contract problem. 2, we'll dive into GenLayer's intelligent contracts. 3, reaching consensus on judgment. 4, building the agentic economy. And finally, number 5, the risks of non-determinism. We are going to break all these complex concepts down step by step so it makes perfect sense. Let's get into it. All right, kicking things off with Section 1, the smart contract problem. So look, traditional smart contracts are phenomenal at deterministic logic. It's pure, indisputable math. Think of it like a really stubborn vending machine, you know? Put in the exact right coin, get the exact right snack. It's simply, if X happens, do Y. If Ethereum is over $4,000, execute the trade. If the code is true, release the funds. Boom, done. But real life isn't always that simple, is it? Real-world problems require actual interpretation. Imagine a smart contract that has to answer, did this construction crew actually finish the physical milestone? Or does this random legal document satisfy the terms of our agreement? You can't just solve that with simple math. They require reading text, checking external websites, and evaluating messy, unstructured information that definitely doesn't fit neatly into a simple true or false binary. Which brings us to Section 2, GenLayer's intelligent contracts. Now, what's really interesting about this is how they bridge that gap. To fill this massive void between rigid code and messy real-world ambiguity, GenLayer defines itself as an adjudication layer for the agentic economy. The absolute best way to frame this in your mind is to look back at history. Bitcoin brought decentralized consensus to money, right? Then Ethereum brought decentralized consensus to programmable computation. Well, GenLayer wants to bring decentralized consensus to decisions that involve meaning, ambiguity, and real human-like judgment. To actually pull this off, they use a brand new primitive called intelligent contracts. And get this, instead of forcing developers to use a blockchain-specific language like Solidity, these are just written in Python. But the true game changer here is what they can actually do. These contracts can process natural language. They have direct external web access to pull real-time data, meaning no more relying on a third-party oracle. They can even do image processing. It is literally opening up an entirely different design space by replacing strict deterministic code with AI-based reasoning. Moving right along to Section 3, reaching consensus on judgment. So here's the million-dollar question. If you ask a math question, everyone gets the same answer. But AI models, they interpret things differently. So how in the world do we reach consensus? GenLayer solves this with a super unique mechanism called optimistic democracy consensus. Let's walk through the 4 steps. First, when a transaction comes in, one validator gets randomly selected as the leader to run the intelligent contract and propose a result. Second, the other validators independently evaluate that same transaction using their own AI models. Third, they vote on whether the proposed result is valid based on the contract's rules. And fourth, there's a finality window for appeals. Basically, if someone looks at it and says, whoa, this AI result is completely wrong, they can appeal it, and a new, much larger group of validators reevaluates the whole thing. It's an architecture that fundamentally accepts a hard truth. AI won't always give identical answers. So the crucial point is this concept right here, the equivalence principle. And I want you to really absorb this because it's massive. The network doesn't need every single AI validator to say exactly the same thing word for word. It just needs them to agree on the meaning that matters for the contract's decision. This completely shifts the entire model of blockchain consensus from matching identical bits of data to matching the core intention. It's wild. Here is how that brilliantly plays out in practice. Imagine validator A's AI model outputs the sentence, "The applicant satisfies the requirement," but validator B's model outputs, "The evidence indicates that the requirement has been fulfilled." Now, a traditional deterministic blockchain would instantly reject this transaction. It doesn't match byte for byte. But GenLayer's equivalence principle recognizes the functional equivalence. The network can look at those two different sentences and agree, yep, they mean the exact same thing, allowing the contract to proceed seamlessly. Okay, let's jump to Section 4, building the agentic economy. The sheer breadth of possibilities here is just staggering. Because these intelligent contracts can read the web and process language, you can build decentralized prediction and resolution markets that literally fetch their own outcomes. You can automate complex dispute and milestone workflows in businesses. You're looking at things like content verification, processing messy insurance claims, automating regulatory compliance, and yeah, even running DAOs that are governed entirely by AI. Just to be totally clear, GenLayer isn't trying to replace all traditional smart contracts. You're not going to use this just to send your buddy $5 for coffee. Instead, it unlocks the complex, nuanced decisions that simply cannot be expressed as strict code. But the deeper thesis here, the real aha moment, is about resolving machine speed disputes for autonomous AI agents without relying on a centralized operator. Think about where we're headed in the near future. AI agents are becoming more and more autonomous. Soon, they'll be negotiating, buying, selling, and entering complex agreements with other AI agents. But what happens when two autonomous machines inevitably disagree? A human mediator? Way too slow. And a centralized corporate backend? Well, that defeats the entire purpose of Web3. GenLayer aims to act as that decentralized trust layer capable of resolving those disputes at lightning machine speed. Finally, we arrive at Section 5, the risks of non-determinism. Now, look, you can't talk about a system this ambitious without doing a really thoughtful, honest analysis of the inherent risks. GenLayer's model is incredibly powerful precisely because it embraces things that traditional blockchains normally try to avoid at all costs. We are dealing with known trade-offs here. First off, AI outputs are intrinsically non-deterministic. The web data an intelligent contract relies on today, it might change or just completely disappear to raw. Let's zoom out and see how this all builds into a monumental shift in network architecture. Traditional blockchains follow a very linear, strict path, code to execution to consensus. It's pure computation. GenLayer's model is an entirely different beast. It flows from evidence to AI reasoning to validator evaluation to consensus and finally to an on-chain consequence. So we are no longer just asking, did this exact mathematical computation happen? We're asking, does this result actually satisfy the rules and evidence defined by the application? It is a massive leap from pure math to actual on-chain judgment. Which brings us to the end of our explainer and honestly leaves us with this really powerful, lingering question. GenLayer's ultimate bet isn't about claiming that AI can think. That's a philosophical debate for another day. The real practical question they're asking the world is this. Can a decentralized network reach consensus on what AI thinks? Because if the answer is yes, the design space for what we can build on-chain is about to get exponentially larger. Thank you so much for joining me to explore this incredibly fascinating source material today. I hope you got a ton out of it, and as always, keep learning.